Good afternoon, team. Today, we'll be discussing a very interesting and important topic. As you can see on the frame, titled Digital Twin. We're going to be discussing the definition, what does this mean, the concepts behind it, where it can be applied to, and the future trends or all that you have. So, I'll just a quick introduction of the members of the team. We have Mr. Steven Owolaye, myself. Uh, we have Ibuka Oji, and we have Thomas Haruna. This brilliant minds came together to, to give you what you have today. All right, sir. All right. On our table of content, we'll be dealing with the definition of digital twin. What is digital twin? We'll also talk about how it works. There's a question that will probably come up while we discuss it, which is what simulation, because uh, it sounds similar to simulation, but it's not simulation. So we'll be giving you the differences between the twin and the simulation. We'll talk about different types of digital twin, the technical architecture, benefits of the digital twin, applications by industry, the risks and challenges currently being faced in that, you know, industry, future trends and outlook, and then we share our final thoughts and conclusion. All right, so I'll just do a brief introduction before I hand over to my colleague. Um, so the question, what is digital twin? I'm going to read out what we have on the screen first, then I'll try to explain it the best I can. So the digital twin is a real-time virtual representation of a physical object, system, or process. It mirrors the behavior and conditions of the real-world counterpart through continuous data exchange enabled by sensors and Internet of Things. Now, this definition looks ambiguous, but what it's basically saying is, like I said, digital twin is very similar to simulation. It means that, for example, we're in this office, and let's say, yeah, so in the NEITI, we have different laptops, we have different printers, we have a safe here, we have different things. Number one, it uses Internet of Things, uses machine learning and AI to replicate what you have in a physical structure. For example, how we have this office. Digital twin is attaching sensor to physical components of the office and their behaviors and replicating that virtually. So it's called a twin because it is, if you look at identical twin, they look exactly alike, right? Now, when we get to the difference between this one and simulation, you get a broader, you understand, explanation once Mr. Steven gets there. What digital twin basically is replicating what you have in the physical structure of things in real time. You understand? So when you replicate the sensor on machine learning, the virtual representation of that physical component learns from what you call it, what the physical component is made up of in real time. For example, I'll give you just one example, then I'll hand over. Is for example, you want to check what will happen if you overload a plane, right? Some will say you can use a simulation, but a simulation is something like I said, we'll talk about it later. A digital twin, you can have a virtual replication of, okay, this is what will happen if you overload a plane. It is going to give you an exact answer, or this is what will happen if you pass this threshold. Let's say when you are trying to fly and you can open the emergency exit, it will give you the exact thing for that exact plane, what will happen. So you don't have to practice in real life. So I think that's where I'll drop the baton and you can continue from there.
But based on the topic as you have said, digital twin, before we talk about the digital twin, I'll talk about Internet of Things. Internet of Things, we talk about AI, and we'll see how they are related to digital twin. Internet of Things is just interconnections of device, physical device that is embedded with sensors and Internet of Things uses sensors for tracking of things. It uses software for a particular task, and there must be a connectivity that is for Internet of Things before you can say, okay, this device and Internet of Things. And when you talk about AI with Internet of Things,
Yes, ma'am.
okay. So when we talk about AI and the connection with the Internet of Things, that means that the data you get from the Internet of Things you can use AI to do analysis. You can use to do analysis to predict things. So the that led us to this digital twin. This is an advanced Internet of Things and AI because if you use Internet of Things with AI, you will not be able to replicate it. So the main use of the main features of digital twin is that you can replicate virtual replication of the object. It's not that you are doing analysis, but you can see, you can have a virtual image of such things, So that is the main advantage, the main features of digital twin. This virtual replicate allow companies to monitor, simulate, and optimize their operations in real time, providing a bridge between physical system and digital intelligence. Because once you you have a sensors and you could get data from a particular thing, you'll be able to use this this digital twin to replicate the picture and be able to carry out analysis. So we want to look at what makes how it works. The first thing I have said is Internet of Things. You need a sensors. You need to sensors to identify something. And once that thing is being identified, the next one is you have Internet of Things, you have software. What is the main purpose? What do you want to get from that thing you have identified? That is number two. Number three is there must be a connection. You want to connect it to something. That is number three. And that is all about Internet of Things. That is the function of Internet of Things. So the next function is visualization. That is, you want to have a picture of it so that it will become real. It look like real to you. A replica of it become real to you. So that is how it works. Number one, sensor attached to physical assets collected real-time operational data. This data is transmitted to a cloud-based system that holds the digital model. Number three, artificial intelligence and machine. Our machine learning process the data to replicate behaviors, predict outcomes, and recommend actions. So that is the third, that is the next part, which is carrying out analysis. So the reason why we can't say this is same as digital twin is same as Internet of Things is AI is that AI will only do analysis. Let's say, for instance, you have a sick person on the bed, and you have Internet of Things that you have the sensors to scan the body and say, okay, this is what is wrong. So Internet of Things will only get you the data. Artificial intelligence will do analysis of what is wrong and what is not. But this digital twin, it will give you a picture of it. It will give you a digital picture of it. So that is that. That is how it works. I want to see the difference between the digital twin and the simulation. The digital twin and simulation. So simulation provides static one-off prediction based on present input. Digital twins offer a dynamic live feed that updates continuously. Simulation, that is the modeling of something. You have a picture, you're making a picture of something. What makes it different from digital twin is that it uses a sensors. Digital uses a sensor, so it is a real-time event. It is a real-time event. So the first feature is data source. Simulation, that is, you want to model something. That means you have the data you are working with. Just like you want to carry out a visualization of some data using the Power BI. These are data that you have before. These are data you have before. But digital twin is not only the past record. It deals with what is happening now. It deals with what is happening now. For instance, you use a sensors or AI that detects sickness or one problem or the other in the body, and you want to make analysis on it. So digital twin will allow you to see the details of such thing in real time, not the past record. So that is the first difference, which is data. It is real-time sensors driven. Number two is interactive. That is, it's, under simulation is limited. That is, you only have the past record. You can only use the past record to do analysis. But in digital twin, that is advanced AI or advanced Internet of Things, it is continuous because as the data are changing, you are seeing a new model, you are seeing a new picture of such thing. Number three, the output. In simulation, you have a single scenarios that is only have a visualization of this particular data. But in digital twin, it depends on what you want to see. It depends on what you want to see. Let's say let's say for instance, that is you can see multiple results, multiple real time results. So that is under that. And the last one is learning ability. That is, we have digital to uses AI, that is artificial intelligence. That is, as the thing is changing, the there is AI allows feedback, powered feedback loops. So that is the difference between the twin and simulation. And the summary of that is that digital twin is a real time. It carry out real time analysis. It carry out real time visualization of the data. Hello? Yes. Okay. Okay. We have type of digital twin. Okay. Type of digital twin. Or let me just say, in what areas can we use digital twin? We have product twin. That is the model individual product during design, productions, and after sales services. That is, those are working in sales of businesses. Number two, we have process twin, represent manufacturing or business workflow for real-time process improvement. System twin, it simulate large-scale environment like factories, supply chains, or small cities. This works in, let's say for instance, if you have watched all these Chinese movies, all these real estate, where you have when you go to their companies, they will show you that okay, this is what we have, this is the buildings we have. You can use a digital twin to give a digital representation replicate of such building, and it will be able to show you the analysis of all that is inside, just because there is sensors and there is connection. There is connection between the physical thing and the sensors. And the last one is human body twins. That is when imagine in healthcare, modeling organs for diagnostic or surgery planning. That is, now they use this is an advanced method in medical care. That instead of for carrying out for instance surgery for to check the health of the person, to check what is wrong and what is not. So technical architecture, core component, that is the physical asset of digital, which is physical asset, which is machine, vehicles, buildings. These are the physical assets. What is it talking about? It's talking about the the physical aspect, because it's all about replication of physical thing. It's all about a replication of something that is physical. So it could be a machine. You want to detect what is wrong with the machine. You want to picture what is wrong with the machine. So it will give you a detail of such kind of thing. So it could be a vehicle. It could be a vehicle. When we have our internet, we talk about the Internet of Things. We talk about cars that are doing that drives without the driver. So when you can use this vehicle is one of the physical asset of it's one of the physical asset, and we talk about building. They use it in real estate. When you use it in real estate, you have a digital replica of what you want to buy. This is the type of building I want to buy, and you have the replica in a digital form. You will see it and it will look like the main building, and it will reflect the details. And I talk about it depends depends on what you want to see. So you can scan and you could see more of the details. The second part is digital replica. That is the virtual model updated in real time. That is the virtual model. That is the replica of the physical device, the replica of the machine, the vehicles, the components. Let's say someone is on the bed, and after they've carried out the scanning of everything, you have the virtual image, the virtual replica of such person, and then you can zoom you can zoom and do your analysis. The third one is digital thread, that is continuous data stream that links the two. Continuous data stream that links the two. That is that point where you are seeing the similarities when you are trying to compare the virtual object and the real object. You discover that both are the same. Both are the same. So these are the architectures of it. And the next one is Internet of Things devices. Internet of Things devices, that is, there must be a connection. Internet of Things, there must be a connection between the devices. And cloud platform. Cloud platform. The next one is artificial intelligence and analytics. I said something, I said the three are connected. Internet of Things, AI, and digital twin. So it uses artificial intelligence for carrying out analysis. For carrying out analysis. And the last one, that is what make it special and make it unique, is that augmented reality, that is virtual reality for interaction. For interaction, that is, it doesn't just stop at analysis. That is, you can use it. You can have a picture or a picture replica of the real of the physical object of the physical object. So the key benefit is number one, predictive maintenance, detect failures before they happen, reducing downtime and repair costs. That is ability to use it for predictive analysis, to predict something, to predict something. Number two, faster innovation, simulate and test new products virtually before physical prototyping. So it's used for test. It's used to test new products virtually. That is, want to see that okay, this physical thing we have used, this physical thing that has been produced, we want to test how it works. We want to test how it works. It's just like that virtual reality. You can use this to test how a product works. Operational efficiency, streamline workflow and energy use through real-time monitoring. Streamline workflow and energy used through real-time monitoring. That's for monitoring. And the next one is informed decision making. Simulation offers insight to improve safety, performance, and cost control. That is, it reduce cost in businesses, or in the sense that instead of a physical instead of a physical test of a device, you can do a virtual test and see how a thing work. I'll just give an example of we have under medicals, we have this virtual reality that they use to picture how to dissect all these animals, and in medical schools they put all these virtual realities to train students on how to bisect or carry out surgery. So it's safe. It's better than doing a physical one. So it's save cost. So application by industry, manufacturing, real-time monitoring of production lines, reduce defect and waste. Smart cities, urban planning, infrastructures, management and emergency response system. Under healthcare too, we have simulated organs for personalized treatment plan or surgery rehearsals. Next slide. Number four, aerospace and automotive. aircraft and car diagnostic, design testing, and in-flight monitoring. Number five is energy, that is optimize grid performance, predict outage, and manage renewable energy flow. This is just like the applications where it can be applied. It can be applied in manufacturing. It can be applied in manufacturing where you want to test what you produce. You want to test what you produce and how it works. How it works. So you can have a physical replica of it and test. So the next one is we have cities. This is just like when I talk about real estate, you'll be able to see a picture of something instead of going to, let's say, instead of going to the site, you can see the picture of it and the details. Healthcare, can also be used in terms of health for health. Aerospace, that is, you can use it to, since it uses a sensors, you can use it to detect, to analyze, to make analysis and find where there is fault, just like artificial intelligence for analysis. But this one will give you a picture of it to monitor, to analyze energy. The future trend and out. Okay, we have risks and challenges. What are the risks and the challenges of number one? Data security. Constant big data exchange opens potential cybersecurity vulnerability. Constant data exchange opens potential cybersecurity vulnerability is because it uses is based on the data it receives. It's based on the data it receives that it work with. So that is a data security. There must be cyber security for it to function well. Number two is privacy concern. Personal or sensitive data may be misused or insufficiently protected. Number three, complexity and cost. Initial setup requires high investment and infrastructure and skilled personnel because number one, the reason why I say is it takes high investment is that you must have for everything you want to do, you must have Internet of Things. The cost of Internet of Things and the AI. I said the three works hand in hand. The next one is integration issue. Compatibility across systems, vendors, and platform can limit effectiveness. So the future trend and outlook is that what are we expecting? So, so what are we expecting? Should we be expecting? Okay, the digital twin market is projected to exceed 120 billion by 2030. That is by 2020, driven by Industry 4.0. As I said earlier, that this is an advanced Internet of Things and artificial intelligence. Human digital twin will aid personalized medicine and virtual diagnostic. That is most especially in the medicine line. Before a drug is being used, you can use a digital twin to test the drug, by by having a replica of the person taking the drug. So when you test the drug, you know the effect of such drugs in the body. So when you use a virtual a virtual a replica of human, if a virtual replica of human to test the drug, you will know whether it's effective or not. So it's very useful in this. It's very useful in the medicine line and for virtual diagnostic. AI produce AI powered twin will enable self-learning system in smart factories and cities. In smart factories and cities. That is, I said something. I said it's because of it gives a picture of something. It gives an image of something. It makes learning easier. It makes learning faster. It makes learning faster. And the next one is integration with generative AI and large language models will make digital twin more autonomous and conversational. That is because it involves the use of AI. Then it means it will be more interactive. You navigate through. You'll be able to navigate through on what you want to see and what you don't want to see. So
So I think on the next, thank you. So final thoughts. I think just to summarize what all we've been saying. So a digital twin is an advanced simulator. It's like simulation, but in a more advanced way. I know as many of us have, like the games that we play, like GTA, what do you call it, Call of Duty, all those things. They are simulations that they use to create those games. I'm just giving that as an example. So, but what makes the difference between a simulation and a digital twin is that simulation is not in real time. Like a simulation can be okay. Like for example, we learned recently that in what they call it GTA, the guy, the main character, is actually a real human being. So they picked a character for him and used that to form a simulation of a game. Because in GTA you are in a particular city, either in San Andreas or in New York, or wherever you are. So, but digital twin, just like my colleague has been saying,
Which one is that? Is it GTA?
GTA is the game.
Yeah, okay.
Yes, sir. So, but like for example, let me give you an example. The way
What's
we
the name
keep
of GTA?
is Grand Theft Auto. So it's a game. So a digital twin, for example, if they do a digital twin of this room that we're inside as we are now, will take. So the difference is, like I said, is real time about to AI and machine learning. So we attach a sensor because you see they mentioned human parts as one of those things. So you can attach sensor to everything in this room. Once sensor is attached to one of us, if you come back next week with a different clothes, the machine learning will learn that you have worn a different clothes, and it will study that your behavioral pattern has changed and all of those things. So, for example, if you want to predict that in the next meeting, if you do that thing for let's say for like a couple of months, you say okay for the next meeting, if for example you are giving something that you don't do it, you can predict from that thing how the session is going to behave, how it's going to either scold you or punish you. You can also predict, for example, if somebody is going to be hungry at so time. So that's what makes digital twin more advanced, and I think it's something that is here to stay. It came as a result of the advent of AI and machine learning. So those things have been used to study a lot of. It's called twin, like I said, twin because it's identical. It studies everything in real time. Like I said, I made this mention of this aeroplane stuff, of his medical stuff. Once you have a patient, and a patient comes to you and says, okay, they have appendicitis, and you can attach that thing to that body part. It will give you real time of the stage of that appendicitis. If you have to remove it now or wait longer. If the appendix is going to blow up now, blow up, you understand? So mostly what they use it for is for predictive, predictive, what do you call it? Predictive calculations and analysis and all of those things. You can use it for data too. You can use it for processes. You can use it for all of those things. So our final thoughts: organizations that invest in digital twins is just basically investing in AI and machine learning. Today will gain a major competitive edge in tomorrow's intelligent world. I think with that, we've come to the end of today's.
Okay. All right. Well done. Just only 4 people are on this, and only 2 people talked.
Yes.
Why didn't you give them the opportunity?
Yes, sir. So we actually brought heads together. In fact, both of them were even major when it came to the research of this. But because we were able to finalize how the presentation would go, so we just said, okay, for today, let's all
Okay.
take it then subsequently.
All right. That's fine. Any questions? Okay.
Okay. Like, I understand the simulation part, the difference, but how does it not different? How does it differ from streaming or mirroring since it's in real time? If, for example, a traffic lights, cars are passing, and you want to do a digital twin for that traffic traffic light, is also it can also be a system somewhere that is streaming whatsoever is going on as the cars are passing. So now, what's the difference? Okay, so which in that process, what am I using? Is it streaming? Is it digital twin? Then secondly, please go back to your benefits. For mirroring too? Is it streaming? Is it because all this mirroring too is also in real time? Even if there's sensors, then yeah, where it says predictive maintenance detect failures before they happen. If the idea if the idea of the digital twin is to predict things before they happen, if it's in real time, how do you predict something what will happen when it's in real time? I don't know if that question is clear.
Okay, so how it works is that
Okay, let me add to that. Now, the digital twin, does it mean that the twin, because we have the reality, abi? Then the other one is software based.
Yes, physical and digital.
Okay. So whatever it is that, okay, you give an example that let's say a plane now. What a digital twin of it. So does it mean that sensor has to be on every part of the plane? On the wings, the front, on the tire, the carriage, and all sorts like that. Does it mean that you have to have multiple sensors or it's just one sensor that will be there? Then what she asked about, okay, if you say digital twin, meaning that okay, you want to correct the situation, the plane
Before it
carry load
happens.
now, or is it to be tested on the ground, or when it is up already? I'm looking at a critical situation. Yeah. So how do you?
Then also I have a third one.
Wait, so hold on, sorry.
So I
So
will
we'll not
just go
forget.
together. I will,
Let them
Try not
answer.
to forget. Try not to
Okay.
forget. So we'll not forget. So I'll answer. I think Ebuka also has an answer to this. So the idea of the digital twin is where I'll answer the session go first. Then I'll come to this. So so if you remember during the course of the presentation, Stephen mentioned that digital twin is a very capital intensive project. So the issue of the sensor, yes, the sensor is going to apply to everything. But what makes so there's a relationship and a communication between both the physical and the digital. That's what makes them real time and twins. So the physical is communicating changes to itself to the digital world. So, but the digital world is there on its own. So you want to make a simulation. Now, based on the simulation you have made, you will now make an analysis of what should happen on the physical again. So that is communicating back from digital back to the physical. For example, we spoke about this plane. You can use any other. You can use any other this thing.
traffic light.
Okay, I'll go to the traffic light. Okay, let's see that traffic light now. You mentioned mirror, you mentioned something else.
It's
Streaming.
what's
So
the difference now?
yes, so the streaming I know is the normal streaming. So I don't maybe you define what you mean by your streaming. Mirroring, yes, a twin is a mirror because you are seeing it. You understand opposite this thing. But the key term given to this is your digital twin is an exact replica in real time of your body of no, not your body, your body
Of
of
a
a
system.
system, a component. And that's why I said the difference between your digital twin and a simulator. I can simulate how, for example, if you're going to do this, when NEITI's building was about to be built, the what do you call it? The architect, they drew up a building plan. That is a simulation. You understand? It's a simulation. In fact, now if you want to go and get some houses, you use this AR and VR to see how the house is going to be. But guess what? That is for simulation they use snapshots. A snapshot is just like what we use on our UNAS. It's a backup in time. It's just a picture of in time, or this is how this thing is. It's not updated in real time to how changes. Digital twin, for example, as the house, let's say there's a lot of rain, foundation was not done well, you didn't put those nylons on the foundation, all those things. How it will start soaking and all those things. You can start seeing all those things. Do you understand? So that's why it's very clever because they have to be even they are machine learning engineers that also have to work with you. You understand? On how to okay, this is what we are going to do, so we are going to do. But we have to understand how this thing works in real time. So larger organizations use it. You can even use it for a business model. If this is going to work, how is the public going to like we are going to carry out this promotion for certain products? Is the public going to buy it and all those things? How is this going to play out? You understand? So, like I said, I think that mirroring there might be a different thing for it. Maybe there's another technical thing for mirroring. Maybe if you explain that, I can understand what you're saying. But I I think that's why I said the difference is that machine learning and AI Simulation uses static limited what is snapshots. Digital twin uses real-time back and forth knowledge. Like, oh, there are changes here. It's just like your AI, your chat GPT. The more you chat with it, the more it knows you. To show you that you've not mentioned your name before, but try and chat to your chat GPT. If you're using is it OpenSea or whatever you call it, chat on it and ask what's your full name to tell you your full name. Because it's getting to know you as you are moving on. You understand? I don't know if I think I've now omitted one.
Yes,
So
then let me talk about the mirroring.
Failure. No, so that sorry. Then the failure is like it's what I've said now. It detects failure when you now carry out, okay, this is how this system is working, everything is in real time. And that's the question you asked. Are you with me? Yeah, you're not with me.
I'm serious.
Okay. You said so if it's in real time, you're saying how do you not detect what's going to happen in the future? In real time means that they are just sharing their like the digital is taken from physical, but you are going to now carry out. For example, we say if you want to carry out a heart surgery, and if you say they're in real time, and you don't want to kill the patient first, you want to check if what we will do
To analyze them.
to analyze what we will do.
But people say it doesn't use past data.
No, real. That's I say real time.
That's why that's it.
Do you
It
understand?
collect the data.
It's still collecting. It's a
Yes, it's
continuous
collecting
process.
the data, but now how do you now, if the person is going to die, how are you going to know that what the failure before it will
Okay,
happen when it's
okay.
in real time?
Okay.
So it's like last now say. For example, if you're not updating your OS, if you're updating your OS, it is getting more that. But that's when last did you update? Because if I updated, at least maybe this is not supposed to be happening. The mic issue, you understand? You have greater chance of knowing exactly what will happen when you have more recent data in real time. You understand? Than when you're just taking a snapshot and doing what you have to do.
Okay, let him talk.
Okay, so about how it predicts failure. So real time works with sensors. Like for example now, let me say our server. This like let me just say a CPU. So let me say it just takes a replica of the CPU and all its components. It does not only replicates the what is seen, it also replicates its behaviors and how it works. So now to know how to detect future problems before it occurs. Let me say for example now the sensors and the detects like the temperature and the vibration and the what else? Let me say pressure. So now when the system is working on is in a good working condition, there's going to be a way it operates. So when these sensors detect that it's no more operating the way it's supposed to operate, like maybe the temperature is higher or maybe the pressure is much on it, it will now like detect that okay this thing can break down in so time if something is not done to it.
Based on the behavioral pattern and
Yeah,
how long
so
it might take.
because it already has like a real time of how it was when like how it
Oh,
was.
okay. What you could mean is that you first of all use past data to teach it to know.
That's what we say. Machine learning.
You first of all use past data to teach it
Yeah.
to know what it
To
should
know,
do.
yeah,
Then
the
it's in
behavior.
real time. It will now okay.
Yes.
It's because people said that it doesn't
No, we
use
said-
past.
Okay, so in
Data.
that sense, it means that it's asynchronous communication. I mean, can get and you can pass
And
it
pass
on.
it back.
Which actually talks about the challenges too that unwanted elements can actually intercept
Yes.
if it's not so secure.
Yeah,
Okay.
Let me say something.
Okay, and what I want to say is that analysis have to do with the data of the past and the present. Just normal analysis is okay. This is what happened in the past. We need to predict the future. Now, what this one do is that okay, this is what has been happening before, and now this present one, this is the present state. Do you understand? Let's say, for instance, you use sensors to on this our room, and as a person you want to make analysis on probably let's say this screen. So when you tap the screen, I just talking about the details. When you tap the screen, it's going to give you details of the screen, and it will show you how it was, how it should be, to how it is now. So from there now you know that okay, inside this room, this system is having a fault. It's having fault because this is not the real data I should have. So that is that in terms of problem solving in terms of prevent the future failure or something. Let's say you have a plane and you use a sensors to scan the plane and everything. The You can get the details of every part of the plane, and then you'll be able to know, okay, which one is in the good condition, and which one is not in the good condition.
I understand.
Regarding what she said earlier, I just want to give another example of how it could be implemented. Like for instance, now a jet engine now, it has a physical component and there's also a virtual component that takes record of everything that's happening with the engine, the pressure, and everything else. As similar to a car now, like your car now, some cars have systems now that tell you the temperature, the speed at which the car is going. So that's real time collection of information. So it's feeding into you, so you know what you're working with. And regarding the simulation and the mirroring, let me give an instance now, like weather forecast now. They could tell you that rain is going to fall tomorrow, but the virtual version of it is that it gives you live feed of what's happening, it gives you live feed of radar, of the temperature that is dropping, everything, so you know that this is happening. So you could use that information now to predict what's going to happen next. That's my input on. Okay. Mirroring, yeah. Let me talk to mirroring. Mirroring, so yeah, transmission of data from somewhere to another. You know that what we are doing here now is mirroring. What is on my screen is here. It's being mirrored. Now you can call it streaming too. Because from here, data is being transmitted to here. So streaming is usually used for data, no, video and audio mostly. So that's streaming. You can stream out, then you can stream back. When you are watching Netflix, you are streaming too. So it's almost the same thing as digital twin, but digital twin in it is that there's it's advanced. It's not something very small like this. Yeah, and it gets real life data. You know, this one is getting real life data too, because it's what is here. But it's just only that it's advanced. It's not something that you can say, okay, you are doing on your system or in a local environment. That's to be. That's the reason why I'm talking about artificial intelligence and machine learning. Just like say GPU now. GPU is used on advanced systems for artificial intelligence. If somebody now say, okay, let's use a GPU here, it's just waste of resources. You can't even have the money to buy it. Yeah. So that's just.
One last question. If something should happen to the twin in terms of security, if an attacker should attack this twin, if something should happen to the twin with the one that is virtual, will it also affect the physical system?
If it affects the physical,
Will it?
it affects the physical twin because it's replicating data.
No, the virtual now.
So although our research didn't go there, but of course, if you affect the virtual, you are not. You don't need to affect the physical.
That's the reason why I ask about synchronization and asynchronization. Yeah, even the synchronization is just that one way you get. So, and you don't open the return unless you need it. So, but if you open the return, so that thing can happen.
But I think you can decide if you want to open it or not. So, but if it's the physical that's affected, virtual will be affected.
Yeah, definitely, it's the virtual. If cyber security, if some hackers they want to hack the virtual.
But to what? What do you want to gain?
No, it depends. Like even like this health thing you're talking about.
You just get records.
Where you want to. Yeah, if you want to get records, or maybe this ulcer patient also. Like another thing that you were saying, is it that you were making mention of medical students? Is it that instead of using human being now to do an operation, now instead of using a human being, the students will have to use a virtual human being and operate. Will it have the same effect? Yeah. You are trying to stitch somebody. You are teaching somebody how to stitch fibroid or something that you cut. Is it going to have the same effect as when you are using a physical person?
Yes.
Okay, I will say, I will use this example that Mr. Shegun gave about mirroring. You understand? So when you mirror, when this one is mirrored here, right? But this physical tool, this digital tool is that the one that is mirrored, you can work on it. You
The
can
one
work
that is mirrored.
that is being mirrored, yes. You can work
That's the
on
original
it.
source. The
Okay.
source now.
You
Yeah.
can work on it. Let's say, for example, this is the mirrored
No,
one, right?
use human being now.
Okay.
Me
Now-
now, I'm going through surgery.
Mm.
Is it me that they'll be working on and the team will be
No,
streaming
No.
to virtual?
not you. That's
Okay.
what I'm going to explain. If you play VR games, you see that you even though you might not feel it physically, but you can make actions. You can shoot this. You can start.
Yes, I
I'm sorry,
understand.
but it's a game. You understand? You can. There are even some that they will put like a stick. You know you're on the ground, but it is so real that you feel like you're going to fall because it's showing like you're on the skyscraper. On the virtual one, as a doctor, you already know how to use. You are wearing the glasses. You are seeing a picture in front of you. You're going to be making your hand gestures. I'm sure you've even seen. Let's even take away from the virtual. You've seen cases where doctors use robots. They are not even there, but they just put their hand inside like a glove compartment and they are doing the whatever.
But where will the sensor
Robots.
be connected to
That's
now?
what, to the human body parts that they are working on. But that should be pre-programmed already. Like, okay, this thing can be connected to the human body parts, and you understand.
Okay.
So, but it has taken analysis of what's already happening in that particular person's body. So you will not carry out the operation of the simulation. Although God still owns life, but that thing can be as accurate as possible to tell you that okay, this student might probably kill this patient. You're not ready yet with your skill, you understand? So you need to learn better. That's why I said you can it's not a simulation, it is an exact twin of what you understand. It's just a virtual representation. You can replicate this compound. You understand? Virtual, it's going to actually give you a virtual reality. This is the compound, and this is how if cars are moving like this, if you have sensors to everything here, as they are moving out or moving in, you will see it. Do you understand?
I understand.
Okay, that's fine. Okay, can we just review the presentation? What do you say about the presentation?
The slides are very
Okay, yeah, the text shoot out very well. You can see the white on black, you can read it. Just only that something I observe generally, the text are smaller. Because we are close like this, you can see it. Imagine if it's a hall. Now you put it on a projector and people are far away from it. So they're having difficulty of reading. And you can see you have enough space. Yeah. So you can increase the font size.
Then this your future trend that you put 150 billion in the next
Okay.
by 2030. What is it now? So that I'll know the
Our research is still ongoing. We'll let to you before the close of business.
Okay. That is a good exit.